So now let's get into talking about free body diagrams. Your teachers might refer to these as FBDs, and these just basically describe the forces that are acting on an object. So let's draw our free body diagram acting on this object. So we have a bucket over here. Question for you. What is the downwards force acting on the bucket? You might be saying to yourself, hey, you know what? I know that the object has a certain amount of weight to it, so we could actually call this the force due to gravity, or the gravitational force. Okay, well, what is the force that's holding it up? Because, hey, you know what? The object is not falling down to the ground, right? So there must be a force acting up on the object to keep it up. Now, once again, this bucket is being held up by this string, or rope, or cord. It doesn't matter what it is. We just know that it's being held up by a string. So, in this context, what is the force that's holding the object upwards? And you might be saying to yourself, you know what, let me give you a little guess here, a little hint. The force starts with the letter T. And you might be saying to yourself, hey, you know what, I think that this is the tension force. Alright, great, so that's for this context over here. These are the forces acting on this object. So we have a downwards force, the force due to gravity, and the upwards force, which is the tension that's holding the object upwards. Are there any forces acting to the left or to the right of this object? No, it's just these two. Think about it. Once again, are there any forces acting to the left or to the right of this object? I don't see anything, not in this context. Okay, well, let's change up this context a little bit. Now, the only thing that actually changed was the idea that we got rid of the rope and now the bucket is on the ground. Okay, well, we're still going to have the force due to gravity acting on the object, right? So, in this context, right now, we do have the force due to gravity of the object. The object still has its weight, right? So, what's the reason why the object's not falling through the ground? It's because there's an upwards force acting on the object, right? So, what's the name of the upwards force acting on this object? This is what's called the normal force. And the normal force is present when an object is in contact with a surface. I really want you to remember this over here. So, once again, it's the normal force is present when an object is in contact with a surface. That is going to be a nice clue for you to determine whether or not there is or is not a normal force being present. Okay, well, let's change this up even more. Say if I was to come over here and start pushing on this object, what would the name of that force be called? Well, that's what's called an applied force. An applied force is also known as an external or an exerted force. Okay, so if I'm pushing on the object to the right, are there any forces opposing the motion of this object? Well, yeah. And what's the name of that force called? I'll give you a clue. It starts with an F. And that's frictional force. Notice here that I wrote it as a lowercase f just like this, as opposed to it being like this. And that's because we're going to be dealing with two different types of forces where we're going to have a different subscript. Okay, so let's say this. Say if I'm pushing, and the object is just not moving at all. So it's just not moving because I have not overcome the force of friction. So in that context, what kind of friction are we dealing with? And that's what's called static friction. And that's when an object is remaining at rest. Okay, so say if I'm pushing, and then all of a sudden, boom, I get it to start moving, and it's moving to the right, Is there still friction being present? Well, yeah, you can actually even hear it. You can actually even hear the noise between the object and the ground itself. You hear the rubbing sound or whatever that sound is. And being that the object is in motion now, what's the name of that friction? And that's what's called kinetic friction. which is when the object is in motion. Hey, here's a nice little fun fact for you. Where have we actually seen a term like this before? Very similar to kinetic. Well, didn't we deal with just the previous unit, which was in kinematics? And what did kinematics mean? Well, it was the motion of the objects, right? So it's once again having to do with the motion. Okay, so these are the forces that we're going to be dealing with in this unit.